Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Inshallah today I will to present our paper that's topics about innovation, modern material processing, the study of laser surface roughening, LSR using Q-switch and laser. Before that, let me introduce myself. I'm Dr. Muhammad Zulfahmi bin Bahaudin, Lecturer of Science Department, Teacher Education Institute, Campus Temanggung Ibrahim, Johor. Introduction. LSR is a non-contact process. Since energy transfer between the laser and the material occurs through irradiation, so no cutting force are generated by the laser, leading to the absence of mechanical induced material damage, tool wear, and machine vibration. Moreover, the material removal rate for laser machining is not limited by constraints such as maximum tool force, build-up edge formation, or tool chatter. By the time copper is a nature has a high affinity to oxygen and is readily oxidized when exposed to selected temperature. The degree of oxidation will be generated be a function of temperature, environmental condition, heating duration, surface impurities, or contamination and surface finish of the metal. But the copper has a low cost, high thermal and electric conductivity, easy fabrication and joining, and wide range of attainable mechanical properties have made copper as one of main material for lead frame, interconnect wire, foil for flexible, and etc. LSR being a thermal process induces many adverse effects in workpiece material, which in turn affect the mechanical properties also. So the most of the performance characteristics discussed by various researchers is a lot. So for this paper, the focusing only on surface roughness. So improvement of mechanical properties during laser beam machining or laser surface roughening is a research area of interest. So by Dubey 2007, who reported the reduce the surface roughness to increase the cutting speed and frequency and reduce the laser power and gas pressure. Problem statement. Copper is one of the materials that has a variety of mechanical properties. So, one of the key ingredients to a lead frame in electrical packaging that serve mainly to support chip. But there is still a problem as described by Yoshiko Oshiga Zhang because the poor adhesion force between the copper lead frame. Surface roughness is important performance measure which required to be improved. So, by the improve of the surface roughness, property using LSR is a research area of interest. The elimination of chip either due to the temperature or moisture will cause contact failure. So, this is among a big issue of semiconductor industry. So, various techniques are employed to address the problem. Commonly, the elimination of the surface roughness is using the chemical methods. So the problem of the chemical methods is it cannot be controlled, involve waste or pollution which drive an environmental friendly and require high budgeting. So the economic method drive research to explore a new technique. In this work, laser was used to roughening the surface of copper plate. There are two research objectives. First, to fundamentally calibrate the LSR on copper surface by using laser energy at range of 150 millijoule until 600 millijoule. Second, to characterize the surface roughness including average roughness and root mean square roughness on copper using atomic force microscope or AFM. There are also two research questions. First, what is the effect of copper plate after roughening with laser ablation? Second, What is the morphology structure of the treated copper? Methodology. The experimental setup is illustrated in the figure given. So the laser used is a commercial Q-switch NDX laser manufactured by FV Medical Technology Co. Ltd model AL114. It is operating both at the fundamental wavelength of 1064 nanometer with pulse duration of 10 nanoseconds. So the pumping voltage is varied from 500 volt until 1000 volt from the control panel on the power supply unit. The laser output energy is varied up to 600 millijoule that measure from energy meter Ophir Orient PE, Ophir PE 50 SH detector. So the laser was focused using a lens of 100 millimeter focal length to achieve enough energy density for a roughening process. Next material. A pure copper plate with a purity 99% having a smooth surface was employed as a specimen. So the thickness of the copper plate is 2 millimeter. So the copper plate is shown in figure given. So the copper plate is normally used as an integrated chip lead frame. So the copper plate was cut into pieces with a dimension of length and width of 2 multiple 2 centimeters square. So the specimens are exposed with laser energy at the range of 150 millijoule to 600 millijoule. Next, sample characterization. So the treated samples are characterized using atomic force microscope AFM in figure given. So atomic force microscope is a high resolution type of scanning probe microscope SPM that can resolve features as small as an atomic lattice in a real space. Figure given show a Seiko instrument INS S11 SP 1380 Newton atomic force microscope. It is one of the foremost tools for imaging, measuring, and manipulating matter of the nanoscale. AFM has a much broader potential and application because it can be used for imaging any conducting or non-conducting surface. For answering the research objective 1, to fundamentally calibrate the LSR on copper surface by using laser energy at range of 150 millijoule until 600 millijoule, so it is found that the laser output energy was measured as a function of pumping voltage. A calibration curve is shown in the figure, so the laser output is found linearly increase with pumping voltage. So the gradient of the graph represents the conversion efficiency of the laser, which is 0.21 millijoule per volt with a threshold voltage of 601.47 voltage. The laser energy is chosen from the calibration of the Q-switch NDX laser for optimizing the beam spot on the burnt paper. So the table is shown the selected laser energy at the various pumping voltage for this experiment. For the graph also, it found that the minimum area of beam spot and the peak intensity of the beam spot are plotted against laser energy. So the results is represent the minimum area and the intensity of the beam spot are found linearly increased with respect to the laser energy. So this indicates that the higher the laser energy delivered to the target, the greater the beam spot will be generated, as well as the higher the intensity or energy density will be produced. Is generally the current laser used in this experiment capability to produce energy density. Next, by answering the research objective 2 to characterize the surface roughness, including average roughness and root mean square roughness on copper using AFM or atomic force microscope, figure in A, it's shown that a surface roughness and laser energy of 161 millijoule, a morphology structure 2D image, and B, figure show a roughness, surface roughness in 3D image. Figure show that a surface roughness at laser energy of 2 to 4 millijoule. Figure A show morphology structure of 2D image. B roughness surface for 3D image. Figure also shown that a surface roughness at laser energy of 320 millijoule. Figure A show morphology structure 2D image. Figure B show the roughness surface 3D image. Figure also show that the surface roughness at the laser energy of 409 millijoule. Figure A show the morphology structure 2D image, while Figure B show the roughness surface on 3D image. Figure also shown that surface roughness at the laser energy of 465 millijoule. Figure A show a morphology structure 2D image, while Figure B show a roughness surface 3D image. Figure show a surface roughness at laser energy of 531 millijoule. Figure A show morphology structure on 2D image, while Figure B show the roughness surface on 3D image. Next, table show that the RA means average roughness, RQ means root mean square roughness, RSK means surface skewness roughness, and RQU means surface kurtosis roughness. So from the table, it shows that sample A, B, D, E, and F have a positive skewness as RSK is more than 0, which means that the copper surface having a valley fill in or a high peak, while the sample C having a negative skewness as RSK is below than 0. It means that the copper surface having a deep scratch, while sample A, B, C, D, E, and F having a kurtosis as RQ is below than 3, which means that the copper surface having a few high peaks and low valley or having a bumpy surface. Next, the figure show the surface roughness as a function of laser energy. So from the graph, it shows that the RA or average roughness and RQ or root mean square roughness is increased linearly with the laser energy. So this indicates that the surface roughness is processing is strongly depend on the laser energy. So the stronger the laser energy, so the higher is the surface roughening. Next discussions. Average roughness or RA and root mean square roughness RQ or RMS increase linearly with laser energy. So we can say that the surface roughness processing is strongly depend on the laser energy. So the higher the surface roughening, the stronger the laser energy. In this work, the pulse duration is 10 nanoseconds, meaning that the period taken for the heat conduction as well as for quenching. But amazing, within such ultra short time, the melting and resolidify can take over at once. Imagine that the energetic of the focus laser will micro breakdown is actually providing peak power of 46.5 megawatt within 10 nanosecond time. Furthermore, the breakdown is associated with plasma formation, which has temperature more than 100,000 Celsius and high pressure from shockwave. So the condition carried out by the indirect laser is much higher than the melting point of copper is 10,850 Celsius. So therefore, the energetic power delivered by the laser smashing the copper surface and induce roughening. As a conclusion, LSR process can be beneficial technique for roughening the copper surface because the process is fast, simple, and economical better than roughening usual chemical method, whereby this technique cannot be controlled, involve waste or pollution which drive unenvironmental friendly and require high budgeting. Therefore, by improve the roughening surface, can prove this technique can be applied to improve the adhesion force of the IC lead frame and innovation modern material processing. That's all. Thank you.